Here we're going to look at one more example of creating a scatter plot and then drawing a linear model through two specific points on that scatter plot. And then we'll find the slope and write the equation of that model. This is a good example because of the context that it is, and then also we refer back to it later on in the semester. So they tell you, let R be the death rate, the number of deaths per 100,000 people from heart disease in the US for the year that is T years since 1960. In 1960, the death rate was 559. So the way you interpret that is, not that 559 people died due to heart disease, there were 559 deaths for every 100,000 people. So if there were only 100,000 people in the US, then you would expect 559 deaths due to heart disease. If there were 200,000 people in the population, you would expect 559 times 2 to be the number of people that died due to heart disease. If there were 1 million people in the population, that's 10 times 100,000, so you would expect 5,590 deaths due to heart disease. So if you think about the reason why they give you a rate like this in per 100,000 people, the idea is to be able to make valid comparisons. Rather than just give you the number of people that died due to heart disease, if I were to tell you 500,000 people died due to heart disease, well, is that a lot of people? Compared to, say, 100 people dying due to heart disease. Well, it's all relative. If you have a very large population, that 500,000 people may not be a lot if you have a huge population. 100 people may be a lot. It doesn't sound like a lot, 100 people, but it may be a lot if you only had 500 people in your population. That'd be 20% of them died due to heart disease. Okay, so what that per 100,000 allows you to do is make a valid comparison from one country or one region to another. So if the US had 559 deaths per 100,000 people, and let's just say Canada had 700 deaths per 100,000 people, then you would say the US is doing better in treating heart disease. Or that's one conclusion you might be able to draw, because they have a lower death rate. Because of the size of the populations are different, you don't want to just look at the number of people dying. You want to look at it as a rate like this, okay, per 100,000. So I'm not going to belabor the point on that. Hopefully you understand what I'm talking about there. Much of the time when you get health statistics, they will say it's the number of infections or the number of deaths or number of cases per 10,000 people, 100,000 people, okay, just depending on what they're looking at. So you see that come up a lot, especially in the health field. Okay, so to make a scatter plot of the death rate, we should be able to do this. You have the year. Now remember that T is the year since 1960. So the first T value is going to be 0, and you want to plot a death rate of 559. So I'll give you a few minutes to do that. You want the year since 1960 across the bottom, and then the death rate up the side. So you will have to scale your axes, but this is a good practice question. So pause the video, and I'll put the answer up. Okay, so here's my scatter plot. Ignore the red line just for a minute. That's the next part. I used a scale of 5 across the bottom for the years, and then 50 going up the side for the scale. So yours should look fairly similar to mine. In part A, after you draw the scatter plot, it says find the slope of the linear model drawn through these two specific points. So that's what I did here. 10, 493, that's this point, and then the other point is this point. So I have them circled. So that is the line you need to draw through those two specific points. Now we're going to find the slope of that linear model through those 2 points. And remember, the only thing we know is that that line passes through these 2 points. We don't know that it passes through any other of those points. It does look like it's pretty close to the intercept right here, so it looks like it should be close to 559, but we don't know that for sure. So the only 2 points we're going to use are the ones that they tell us that we know are on the line for sure. So find the slope. Again, you can pause the video. So the slope ends up being negative 314 over 40. So in 40 years, the death rate decreased by 314 deaths per 100,000 people. If you do that division, you end up with negative 7.85 deaths per 100,000 people for every 1 year. So explain the meaning of the slope. If you put the units on it, you're 90% of the way there. So what is happening with the death rate? Decreasing by 7.85 deaths per 100,000 people every year. Okay, so the death rate decreases by 7.85 deaths per 100,000 people every year. And then the next part, write the equation of the linear model. So again, we have these 2 points that we know are on the line. We have our slope. So we're going to plug in our slope and one of those 2 points into our y equals mx plus b. I used 10, 493 for x and y. Solve for the b value, and you end up with 571.5. So our equation, instead of y equals, we have r equals, okay, the death rate equals negative 7.85 times t plus 571.5. Now I want to make a point there that that vertical intercept, and this is part D, so I guess I'll explain it what I mean here. The vertical intercept and explain its meaning. Well, our vertical intercept is at 571.5. So 0 is your x value, or t value. And then what does that mean? Well, that 571.5 is a little bit different than what it told us in the table of 559. Okay, so basically what's happening is the linear model that we're drawing ends up being a little bit higher at the starting year in 1960 than the actual value of 559. We're getting 571.5. So our predicted value is a little bit higher. So in 1960, we predict the death rate was 571.5 deaths per 100,000 people. So that's how you interpret that meaning. That was our prediction in 1960. And note that the actual death rate was only 559 deaths per 100,000 people. So that's another example of creating a scatter plot and then drawing a line through 2 points on the scatter plot. And if you can do this one, okay, so work your way through that one, then you're in pretty good shape as far as understanding what to do. And remember that once you get to the 2 points, so once you have the 2 points that you drew your line through, whether I tell you what they are or you pick 2 yourself and draw it, all it is coming down to write the equation of a line through 2 points. And you've done that several times now. You find the slope and then find the vertical intercept, the m and the b values. Just make sure that when you write your equation, you match the variables up. In this case, t and r were the variables. So don't leave it as y equals. Change your variable to the appropriate variable.